welcome to PSCAD tutorial. In this tutorial we will learn how to build a simple power system containing a three-phase voltage source, line impedance and load. Okay, this first point, let's build a simple power system. For that, this is a PSCAD outlook. From here we can go to file, then new, then case 1. You can also case. Now save it. Okay, I am saving this and here write power system. Okay, this is your modeling window. Now you have to create a three-phase voltage source. Okay, so for three-phase voltage source, go to master library. This is the source to source box. Go to source. Now take any three-phase voltage source. Say this. Okay, so copy it by control C, or you can just copy it from here. Go to there and paste it. Okay, so this is a voltage source containing R equals to 0, that is a ideal voltage source. Take RLC, its source impedance is RLC and star point is grounded, and this is a single line view. If you look three phase view, this will look like this. So you have to create three lines for individual phases, so no need of this. Take single line view. Okay, then go to single signal parameter. Okay, this is external control of voltage, external control of frequency. Okay, if you made it yes and click OK, you can just you will have voltage and frequency. You will see voltage and frequency from outside. Now if we want to change the voltage and frequency from outside, you can just uh, click the real constant from here also. You can have the real constant from master library also. uh, where it is found, it is found from here, right? It is from miscellaneous models. Here we will get this real constant. This is integer. Okay, so directly you can have this from here. Okay, now take voltage source. First go to this and help. You will have this input parameters. First configuration, source impedance tab. You can have the drop list. Source impedance is RLC, and then signal parameters. Say external voltage source. Okay, external voltage source, external control. Okay, not the voltage actually in kV. So you mm, remind this, because you have to put a voltage value in kV. Okay, so if we take 230 kV from here, 230 kV from here, or you can just you can just take fixed value from here, 230 kV, right? Now in India our frequency is 50 hertz, and phase shift we are taking 0, because we will connect a load. If we connect another three-phase voltage source, then it we use this phase shift as 10 degree, that is the load angle of the power system delta. So we are taking this 0 initially. Now go to terminal condition, it is inactive resistance, this is RLC. Say take this as it is, don't change anything, this all are inactive. Okay, so I delete this. So this is 230 kV 50 hertz system. Now I'm using with sticky notes, it will be helpful for you. For sticky notes, this is the sticky note. Okay, so if we want to write this, just double click here and write 230 kV 50 hertz. Okay, you can change the font size, alignment, style, all these things. Now, okay, now move your mouse cursor, don't click it, move your mouse cursor, you will find this box. If we click in this box, this will give some arrow like alignment. So this is your voltage source and this is the details of the voltage source, right? Now line impedance, take RL, line resistance and inductance. Take take 10 ohm line resistance and take impedance. You will get resistance impedance from master library also, from passive elements here, right? Here also it is available, and we are taking this from here. Okay, so line resistance is 10 ohm, and what will be the value of line inductance? uh, Line, actually inductive reactance is much greater than line resistance for a well conditioned power system. So take 10 times of the resistance, so 100 will be the line reactive inductive reactance. So what will be the inductance? Actually, uh, our uh, as our x is equals to omega L, right? Where omega equals to 2 into pi into f, where our f is equals to 50 hertz, right? So our L will be equals to x divided by omega. So uh, so x is our 100 ohm divided by omega means uh, 2 2 into 50 into pi. So 100 into pi, right? So if we use calculator here, 100 and 100 will cancel out, 1 by pi, 1 divided by pi will be equals to 0.318. Okay, take 0.32 Henry, it is in Henry, right? So our value of the inductance will be 0.32 Henry. So go to PSCAD model, this is 0.3232. Okay, so this is our line impedance. And take load, say take R load, say this is 10 also. And now if you use sticky notes, write line impedance. Okay, now just move your mouse cursor from here and click on this. So this is a line impedance and this is your load, fixed load. Okay, so this will be your fixed load. Now we have to use a ground connection here. So this is your ground connection. Now how to join these things? Here we will found this wire, W for wire. So click from here, this, click here. So this line is joined. Press escape. Okay, then next click on the wire, join this, escape. Click on here, 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 escape, and here, 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 escape. So this is our primary model of a basic power system containing three-phase voltage source, line impedance and load. Now plot current, voltage and power profile. How to use, how to find the current, voltage. Now if we'll run, this will run. You the mm, notification is given that the project is not requesting any output channel. You are able to plot any result. Proceed with simulation. So we are not taking any plot till. So proceed the simulation. Yes. I will see EMTDC run is completed. So you will see message from here if we just up. This is already run. Now if we want to select the time duration of run, take 5 seconds. 5 seconds. Channel plot step 200 and 50 microsecond means our sampling frequency will be 1 by 250 means 4 kilohertz. 4 kilohertz means 5 seconds will get 4 kilohertz means 4000 data per second into 5 means 20,000 data. No need of that huge data. Just take 1000 here. 1000 here means 1 by 1000 microsecond, that is 1 kilohertz, and you will get 5000 data from 5-second run. Okay, click OK. So yes, you will see the runtime and this is completed. So run is done, but how to plot the current, voltage and um, power profile? Here we have, this is ammeter, this is voltmeter with ground connection, this is voltmeter with non-ground connection, this is our multimeter. Okay, so if we take multimeter, you will get all the required voltage, current, power, all these things, right? Okay, uh, so this will not need, so delete these things and connect the multimeter here. Just click on this and press R. You can rotate these things. Okay, here. Now press where, connect this, escape. Okay, now measure instantaneous current. Yes, yes. Voltage, instantaneous voltage. Yes. Active power. Yes. Reactive power. Yes. We are not taking RMS voltage and phase angle. Okay. And animated display. Yes. Okay. Now you have to mention the signal names. So instantaneous current say IS. Instantaneous voltage say Vs. Active power say PS and reactive power say QS. Okay. Now this is the measurement through multimeter. Okay. Now we have to plot these things. So we have signal name. Signal name first IS. We are taking the instantaneous current and we have to use this. This is your output channel. You have to build a output channel for datas of output parameters. So this is our title is IS and displays title on icon ES. Scaling factor is 1. Okay, and unit of the current is kiloampere. Okay, okay. Now you have to connect this from this escape. Now I'm just copying it by Control C and paste it. We are just replacing this IS by VS, and from here this is also VS, and unit of the voltage is nothing but kilovolt. Right. Now paste again. Just replace I by P, PS. From here also P, and unit of the active power is kilowatt. Again replace these things by Q for reactive power, and this is kilovar. Okay, now run it. So you can see the message is not shown. Hmm. uh, where no output channel is there, so we cannot plot anything. This message is not there. Now how to see the plot? Just right click it, go to graph, meter and control. You can add a overlay graph with signal. This, just click on this and press R, or you can have this arrow and you can select this. You will find this, and if we just magnify this, you will see three phase sinusoidal current, right? And magnitude is 20 0.02 kiloamps, means 20 amps. Okay, now if you can just click on this portion, main graph portion, add overlay graph again for next plot. You can have just right click on VS and go to graphs, meter and control, add to curve. Just right click on the curve and paste curve. So this is our voltage. So just max just magnify this. This will take 7 kilovolt, right? 7 kilovolt. Why it is coming like that? It is not. Source voltage is 230 kV. I think source impedance is, take this ideal voltage source. Okay, now it will, okay, here the voltage magnitude and current magnitude all are increased. Current magnitude is actually source impedance, this default value we are taking, but it is not right. So this is 230 kV, right, for voltage source. Now we can add again overlay graph and again for fourth. You can select this and you can like this. Okay, this is our active power. Go to graph meter, add to curve, click on curve and paste curve. Now go to QS, graph meter and control, add to curve, click on this and paste curve. Q QS. Oh, sorry. This should be changed. Q. Okay. Okay. Now just click on this. Click on this. Right. So this is our P. P is 100 kilowatt, 100.7 kilowatt from here, and Q is 506.2 kilowatt. This is very high reactive power. So these parameters may change to reduce the reactive power, because active power is always high for a well conditioned power system than reactive power. So this is some these parameters must be changed, or this source impedance must be changed from. Okay, so next point B is already done. Now use variable load. Variable load. How to use variable load? This is a fixed load, right? Now go to this and we will have three phase loads. This is the variable RLC components. Take this, uh, copy from here, right? Just right click it, copy it and paste it here. Now just replace this by, just click on this and press R. So this is our resistance variable. Just go to this, only write this as R. Okay, source voltage, though no need of mentioning source voltage of R, because R has no voltage initially. Press OK. So this is R, and we can vary this R from outside. How to vary? We use slider. We can use slider. We can use rotary switch. Okay. So where we will found from here. This is the rotary switch. This is the slider. This is the slider, and this is the rotary switch. Okay. And we can find this from the master library as well. This is an input output device. Here we can found this is slider, this is dial, means rotary switch. Okay, so go to power system, and if we use slider first, then just delete the rotary switch. If we use the slider first, just uh, you can change the variable RLC from here. We are taking just R for resistive load. Okay, now Actually, we cannot use slider here as we cannot mention. Oh, we can use, yes. Just title R, group title on icon, yes, display. Maximum value take 50 and minimum say 0 and initial value say 10. This will be our kilo ohm. Okay, just press OK. Now just mention the signal name as R. R. Okay, and connect uh, uh, connect this R from here. Now we have to take a control panel from here. Control panel. This is nothing but the control panel. Okay, just right click on R, go to graph meters and control, add as control, right click on control and paste it. You will see the slider switch. You can slide this easily by using your mouse cursor. Right, we are taking first say near about 10. Okay, this 9.94 some. So initially we have 10 ohm for fixed load. This is now variable load. Oh, okay. So initially we have fixed load of 10 ohm. So if we run this, and this is almost near about 10 ohm, this magnitude will not change. Just run it. You can see magnitude is not changed much. Now we take higher value of say 36. The current value will decrease and current value is decreased and power requirement is higher. First, our active power is 100 kilowatt. Now it is 204. So just click it and press R. You will have this much amount of active power and this much amount of reactive power. Here reactive power is decreased because resistive load is increased. So there is no. Okay, this is the use of mm, slider switch. Now we will use just rotary switch. We use rotary switch, right? Just click it here, just delete the slider switch and just connect these things with this and double click on this. This is our R. Say not no need of displaying 10 values of R. Say 5. Say 5. So position 1 is say 5 ohm. Say this is 10 ohm. This is 20 ohm. This is 50 ohm and this is 100 ohm. Okay, now just control, we delete it and again we select the control panel and paste it here and just right click on this, go to graphs meter and control, add as control and right click on this and paste it. Now we will have this 5 uh, points here. Here green means this point is selected. So 1 represent 5 ohm. So run this. this we are getting um, we are getting the power, current and voltage um, with our load resistance 5 ohm. If we go to 2, this means 10 ohm. Just run it. Look, 10.7. If we go 3 position, this will be our 20 ohm. So P will increase. Yes, P will increase. If we go to position 4, means 50 ohm, P will increase further, and corresponding current is decrease. Ah, now go to 5 position, this means 100 ohm. Just right. Okay, this P is increased further. Okay, so this is rotor use of rotary switch. Now one more thing remains for this tutorial, this use of meter. So use of meter means we are just plotting these signals from here. We can also have meters. Just click on the control panel, go to IS, go to uh, graphs meter and control, add as meter. Just right click on the control panel and paste it. So we'll have 1.23, the exact value of current. We are uh, not able to uh, find the exact value from the sinusoidal. Here we can assume that the exact value is 1.23. Okay, now if we just want to see the active power, go to graphs meter control, add as meter. Just right click it and paste it. This is 262.36. Now if you run this, this will the uh, the meter readings will change. The PS will remain constant, because here we can see from here this is remains constant, and current will change, because this is a sinusoidal signal, so positive half cycle, negative half cycle. Due to this current will change. So run it. So you can see this is changing, but this is constant. So this is the use of meter, right? Okay, so this is our first module, building a simple power system containing three-phase voltage source, line impedance and load. We're using sticky notes. We plot the current, voltage and power profile. We use the variable load as well. We use slider, rotary switch and meter. So this is end of this tutorial. Thank you.